Hey guys, okay, so since we were not able to get a lesson yesterday due to the assembly, I'm going to do notes on what we were going to be taking. So the problem that we're going to be dealing with is called logarithms. So to spell logarithms, it's going to be as the following: Logarithms. Okay, and the major thing that you need to remember is that logarithms are inverses of exponents. Now, here's the straight up fact here. You're going to either be 50% that's going to get this really quick and 50% is not. The biggest thing that I've noticed throughout the years is that the ones who overthink it make this the hardest topic to learn, okay? This is actually the easiest thing you're going to learn, but it's going to be new. You've never seen this before. You've seen exponents, but you haven't seen logarithms. Now, today we're just going to go through the properties. After we have the properties, then it's all downhill from there. So, let's review our exponents and then we can compare it to logarithms. So on the next page, create a table on your paper. And on this table, you're going to have, on one side, you're going to have the rules of exponents. And on the right side, you're going to have the rules of logarithms. So what we're going to do is compare. I'm going to go through the rules, and then I'm going to do a couple examples, and then I am done with notes. Okay, so let's go for the first rule. When we multiply exponents, so for example, x cubed times x squared, what do we do with the degrees? Well, every time we multiply exponents, we have to add the degrees. So we have x cubed times x squared. So adding the degrees becomes x to the fifth. So in general, we would say when we multiply exponents, we add the degrees. All right, so with logarithms, when we add logarithms, we are going to multiply the logarithms. Because remember, they are inverses, so we're not going backwards. Okay, so I'm going to give an example on the next page of this rule. So, this is what a log looks like. I'm going to add them. Okay, so since we are adding, you don't move log square. What you do is you're going to take this number in front and this number in front, and you're going to multiply those. So that final answer is going to be log 70. And I'm done. Okay? So now we're going to do another one. Log x plus log 7 is going to equal to log 7x. Notice I'm putting parentheses. You should get in the habit of writing that parentheses with logs. Okay, so this is with adding and multiplying. Make sure you have this down. If you have any questions, ask me tomorrow. All right, so now continuing on that table, for our rules of exponents, the next other rule we have is when we divide, we subtract. So let's go over an example of that. If we have, let's say, x7 over x cubed, we simply just do 7 minus 3, which is this x to the fourth. So the generic rule is when we divide exponents, we subtract them. Well, for logs, we just do the opposite. When we subtract logarithms, we divide them. So give yourself a moment and copy this down before I move on to the next page. If you need any time, pause it, because this is in your own time. All right, so I'm going to have log 100 minus log 5. That's going to equal log 100 over 5. Notice I did not write log twice. If you write log twice, the whole thing is wrong. We're going to show you later on where that will be different, but right now this is where we're going to go through the answers. So log 100 minus log 5 is equal to log 100 over 5 because I'm taking these numbers and I'm dividing them. Okay, I can reduce that to log 20. So that is my final answer. Okay, so let me do another one. If I have log 20x minus log 4, my answer is log 20x over 4, which is equal to log 5x. Okay? Make sure you have this written down. Okay, one more rule. So we're going to put exponents on this side. I'm going to put logarithms on this side. Okay, so for exponents, this one's a little bit harder. Right now we have the power rule. So when we have something like this, okay, essentially what's happening is that we're writing x cubed 7 times. Okay, because when we multiply exponents, we're adding. So 3 plus 3 7 times is equal to x 21st. Okay, now a lot of us remember the shortcut that we just simply do 3 times 7. So when we did a power, okay, when we have a power rule, we're basically going to add it. This represents how many times exponents is going through. So for logarithms, when you have a coefficient in front, it is now an exponent. So let me give you an example on the next page. 5 log x would equal, so you're going to take this number and you're going to put it as a power. So it becomes log x to the 5th. I do it again. 4 log x, take that number, put it on the top. Now we have a log x to the 4th. And that is it. These are our final answers. Okay, so let's review on what a logarithm is. Now, an exponent is in the view of this. B to the x equals a, where b is my base, a is my answer, and x is my exponent. So, for example, 3 cubed is equal to 27, okay? Or 3 squared is equal to 9. So 3 would be my base, 9 would be my answer, and 2 would be my exponent. Now, how would I write this as a log? So log is log, base is on the bottom. I think of it as a basement. A is right next to B equals to x. So basically, since the answer was outside, now we're doing inverses, so it's going to be inside. So 3 squared to 9 would be log. We have a base of 3 equal to our power, which is 2, 9. Okay, this one would be represented as log 3, 27, so equal 3. So let me explain more about that because that's very, very different. So for example, if I have log 5, 125 equals 3. okay? How to check that is I take my base, I raise it to a power, and it should equal this number. If that's right, that's how it's written, okay? So let's try this. Log 749. What does it equal? Well, 7 to the what power is equal to 49? Well, 7 squared is equal to 49. So my answer is for log 749 is equal to 2. Now, in a situation where you do not have a base, so let me give an example. Log 100. If you do not see a base right here, my base is always 10. The reason why is because when they created logarithms, we deal with base of 10 for the Richter scale. So if you need to, write a little 10. It will not hurt me at all, okay? So this is just saying 10 to the what power is equal to 100. Well, 10 squared is equal to 100. So it's equal to 2. All right. Last one, log 1 over 100. Okay. Well, we're having it as a fraction, so this should be -2. If you do not understand that, it's because you do not understand how negative exponents work. Because 10 to the -2 is equal to 1 over 100. Because 10 squared is equal to 100. 10 to the first is 10, and then as you keep going down, it grants you to -1 over 100. Okay, so on the next page, the last page, I'm going to give you setup problems. You're responsible to do them before you come into class. I am not going to explain them if one student doesn't have this. Okay, here we go. Okay, so these set of problems you are responsible for, and then bring them in as soon as you come into class.